So this is a quick demonstration of how to plot a graph on the Excel sheet. Select the values which I've got are from the pilot reading from the video, and I'm just simply going to select the readings which I would like to plot and go to insert. And if you click on this chart, you can see that you automatically get the values plotted for you. Now I'm just going to select and change these values on the x-axis. So I just select that, right click, and you get format axis, and you can see that it is every 2. I want to change that to 1. That is, and I'm going to do the same with the y-axis. So you select it, right click, format axis, and it should come up, and I'm going to change that also to 1. I've just elongated this graph. Now the next thing is, of course, you can do is your chart title. Once you select it, you can type in and you could do the same for the titles over here. It automatically selects. We know that is our pH. Enter that and select that, axis title on the X, and we know this is the volume of NaOH. Enter that there. So more or less this gives us the graph, and this is one way to do it, and this is the easiest way. And you can see from here that this portion where there is a sharp increase is the midpoint of that should basically tell us the equivalent point, which will, if you bring that equivalent point downwards and check, you should get what is called as the volume. And once we get the equivalent point extrapolated down for the volume, you can then use that volume to actually determine your molarity of hydrochloric acid. So in this particular case, so this is one. To determine that specific point, I'm going to show you a simple, I'm going to move this right at the side. I'm going to show you another way of actually doing a graphing, and this is basically it's like a derivative, and it is the incremental increase or the incremental slope. So what you mean by that is the slope for every 1 mils is what we are going to calculate. So I'm going to use a simple and show you all, also demonstrate how to use the formulation. So the first thing is click on the bar up there, put an equal signs, open up a bracket, and this is the column C and row 4. So I'm going to type in C4 minus C2. It's the difference between the incremental readings. So C3, close the bracket, divided by, divided by, and it is the difference of these two values. So this one will become B4 and this is B3. So divided by, open the bracket, don't forget the opening and closing of the bracket, B4 minus B3, shut the bracket. So this will give us the value, and if you select highlight it again, you will see that it comes up as a formula. Simply just copy this right down. So this value is an incremental value with respect to each other, and you can see that the highest point is at 12, the highest increment. So you can see that the increments are maybe from 10 to 12, but the highest one is at between 11 and 12, and that's what we have to keep in mind. So the pilot reading basically tells us that the neutralization point or the equivalent point is between 11 and 12. So in this particular case, I'm going to show you another way of how to plot this graph. So you're going to go to, you're actually just going to select a cell outside, and you go to insert and you click on a scatter graph, and it will come up empty because we have not highlighted any X or Y values. So you're going to go on to select data, add data, and I'm just going to I'm not going to go into that. I'm just going to go into the X value, and we know that our X values are is the volume. So I'm just going to select the volume over here, select it down. The 0, 1 is ignored because there is no difference over there. And then you're going to backspace the default value there, and now select from here, select it down, and this will actually give us the actual indication that it is between 11 and 12 mils. So I'm going to say this. Okay, this is a pilot reading, and so it really just gives us a an idea of an approximation. You could then again do the same thing like what we did before. Select the x-axis, and you want to change right click and format axis, and you can now change that to 1 unit, and it'll give you a better spread. And this seems to be fine, so I'm just going to leave it as that. So definitely between 11 and 12 is our actual values. So I'm going to do trial 1 and leave that. Maybe you all can practice with trial 2. So let's do what we did just now, the difference in values. So I'm going to take the difference in values from this to this, then from this to this. So instead of working each one out, you can simply copy it. So let's start with 1 and do the 1 correctly. So here we go. We need to select this. We need to open the bracket, and we are going to look at this values. So the value here is C. So it's C21. So we are going to take this one. So C21 minus C20, close the bracket, and then we're going to divide that by B21, open the bracket, minus B20, close the bracket. So that will give us our value. Select that value and simply once you get the plus sign, just copy it all down. It will automatically copy everything. And you can see from here that the biggest value or the biggest jump is at 11.5. That itself should tell us where our endpoint is. But let's put it on a graph for the sake, since we are anyway using our graphing. So once again, I'm going to not select anything. Click outside, click on insert, go to a chart. It will open up into a blank one. That's what we want. Now we're going to select. So go to select data. We're going to add, and I'm going to select this data. Backspace the Y values and select this data. Yeah, let's select this data. And you can see that we've got the volume, the highest volume at 11.5. So that's good. Now we could also select that, right click, format axis, and do the same thing what we did before. And we're going to make this every 0.1. And so it shows us the highest peak value at 11.5, which is our equivalent point. I just wanted to show you another cool feature which you could use, and you could go back to select data, and you can go into add and go into the x-axis and select that, and then go onto the y and select this value this time. This is the plain volume. And so what I'm trying to show over here is you could plot both the graphs on one single page. This will indicate that this value corresponds to, this was the sigmoidal curve, the S-shaped curve, and this was the steepest portion of the curve, mind you. So remember, we are not taking the 0. We're starting from 11 to 11.9. So this was the steepest portion of the curve. If you check this one over here, it is this portion, so which has been actually brought down because we were titrating just 0.1 mils addition. And so you can see from here that this is the 11.5 value, which basically is what we were looking for. So once we have determined this, you could now calculate by using the formula M1V1 is equal to M2V2. And I mean, we know the molarity of NaOH. We now know the volume of the NaOH, which is this portion. So 0.0961 times 11.5 is equal to the volume of of hydrochloric acid was 10 mils. So you're going to divide that by 10, and it will tell you the exact molarity of hydrochloric acid. Thank you.